Suppose we are given with a dataset of the form presented here. It consists of k plus 1 variables, namely y, x1, x2, etc., xk. Each variable has n measured observations. Among these k plus 1 variables, y is considered as the dependent variable. The remaining x variables are treated as independent variables. In a simple language, what it means is that the values of x variables are under our control. We are free to change the values of these x variables. But the value of variable y is beyond our control. For example, let x1, x2 and x3 respectively denote the amount of water, fertilizer and temperature applied to a plant, and let y denote the yield obtained from the plant. Clearly, x variables are independent here. This is because we can control the values of x variables. On the other hand, y is a dependent variable. This is so because the amount of yield from a plant depends on the values of these x variables and some other unexplainable factors or causes. That is, we have no direct control over the value of y. Now, if we are able to find the relationship of these x variables to the y variable, we will be in situation to predict the yield from that plant in advance. Regression analysis is such an approach to find the relationship between variables and to create a model for prediction purposes. Linear regression model is a particular case of this approach. In linear regression, we always assume that the possible relationship between the variables is linear in nature. After forming the model, we estimate the coefficients from the data using OLS method. After estimating the model, we can predict the value of y for a given set of x values.